Hello, Algebra 2. Today we're going to be looking at reviewing lines. So hopefully you've already worked with lines extensively in Algebra 1. You probably haven't mastered them yet. We're going to review them today, and hopefully by the end of this year you'll be a little bit more comfortable with them, because we do use lines extensively in calculus to find tangents to curves and for other purposes as well. So, linear functions are typically represented three different ways. You may have only worked mainly with one way, and that's all right. So we might be showing you a couple other forms of lines today. And if not, we're just going to get back into the groove of things by working with some lines. All right, so the three forms of a line, especially the one you're most familiar with, I think you should be familiar with this one. If not, you're probably not in the right class. So y equals mx plus b, that's called the slope-intercept form, pretty simply because m represents the slope and b represents where it crosses on the y-axis, in other words the y-intercept. Alright, so that's a form you should probably have used extensively, and it's best probably for graphing. Alright, so another form of a line you may or may not have seen, but which we'll probably use quite a bit today, it's pretty nice for a lot of situations, is this one. So I definitely memorized this one if you haven't already, so you can see that it's also got a slope. And it's got this x1, y1 coordinate pair. That's the coordinate pair of a point that the line passes through, any point the line passes through. So this is called the point-slope form. So we want to write that down, remember the equation, and remember the name of the form. Alright, and another one which I'm sure you've worked with, but you might not really remember that it's a form, is this guy. A lot of the time we manipulate this guy into mx plus b because it's more useful in mx plus b form, but we want to remember this guy's name because we're going to start talking about different kinds of polynomials this year. So this guy is called the standard form of a line. Okay, so we might add a couple things to this list as we go on today, but I think that'll give us a good place to start and make some lines and put them in these different forms. Before we do that though, I want to talk a little bit more about slope. So let's look at this table here. Now this of course doesn't represent every point in space, it just represents a select little bit, 5 points in fact, 5 points of information for us to decide whether we think f of x, this function right here, could possibly be a line. We don't know for sure with just 5 points, but we can decide whether, based on this data, if we think it's a line. So let's look at the change in the x-coordinates. I think that has to do with the slope. So if we look at from negative 13 to negative 7, it looks like that's going up by 6. And then it looks like it went up by 6 again to get to negative 1. And it looks like this one, that pattern is continuing. So far that's good because in order to be straight, a line has to have constant slope. So let's put that. Lines must have constant slope. In other words, their change in their x, the ratio of that to the change in the y, has to maintain the same ratio, otherwise you wouldn't be quite straight. So let's see if the y's, or f of x, because remember that's another name for y, let's see if that changes by the same amount. So it looks like it goes down by 10 to begin with. Oh, still going down by 10. I'm pretty good. This looks like a line, right? Oh, then it went down by 8. So you can see that this was almost a line, but not quite. So f of x here is not a line. It was close, but it looks like it bent kind of at the end one way or another. So this is not a line. So remember, when you're thinking about slope, m, which we're going to think about as a change in y over a change in x, you can think about that as a rise, if you want, rise or fall over run. That has to be constant if you want it to be a line. Okay, let's start making some lines. Excuse me. So our first line, we already have a slope targeted. Let me move this kind of out of the way. It's a little bit distracting. There we go. So our first line says make it have this slope and pass through that point, 10, 24. You know what? I think I might change that point. Just give me a second. I think that's going to make our first line be a little bit difficult, and I don't want to do that quite yet. So let's change the coordinates to that. We can make it go through any point That's not a big deal, but I want it to be easier this first time. So since we've got a slope and a point, my class usually jumps out and says use point-slope form, even if they've never used it before, and I think that's a good strategy. So write it down first, just so you start remembering it, because you do need to know it without looking at your notes eventually. So we're going to go y minus the y-coordinate we're supposed to go through, which looks like it's 10. The slope is -3/4, so we'll put that in for the slope, and x minus the x-coordinate we're supposed to go through, which is 24. Now that's the point-slope form of a line, but I think we probably want to graph it, so I'm going to distribute to get mx plus b. Now if you're saying, why didn't you start out with mx plus b? I could have. I'm just demonstrating a couple different ways to do these problems. I think this way is just about as short. We'll do mx plus b on another one. So when I go negative times negative, that's going to be a positive. And you know what? I'm going to be smart here. 24. Instead of going 3 times 24, that's a big number. I'm going to go 24 divided by 4 because ultimately that's the same thing, right? Because this is like -3/4 times -24. And this reduces down. So I think that that is going to be 6. So it's going to be plus 3 times 6. So finally, I'm going to get -3/4 x, add that 10 to the other side, so I'm going to have 18 plus 10 is 28. And now I can come over here and do a quick sketch of my graph. Might want to, since it's up at 28, I might want to go like this, right? So we'll just pretend that this is like 10, 20, 30. So our line is going to be, have a y-intercept of about 28, something like that, and it's going to go down 3, about like that, and over 4, so you can see I'm not being very careful, 1, 2, 3, 4, but that's good enough for you to get the point that this is our line right here. Okay, let's do another one. So example 2 says make a line go through 2 points. So let's try that out.